second talk, I wanted to just share one news that our meetup is now a member of CNCF meetups. So we can expect more, thank you very much. We can expect more people attending, and we can even request speakers who are part of CNCF organizations. So we will be benefiting from it. So for our second speaker today, we have Madhu Wali. He is a principal software engineer at SkyTel, and he's working on a CNCF project called SPIFFE, which is about identity between microservices and workloads. So thanks, Madhu, for presenting today. Give him a big hand. So you're going to be recording today.
Yeah. Hear me all right? Can you guys hear me all right? All right, so sorry I did not give Sudhanshu how to pronounce these things, so he kind of did a pretty good job in say that. It's called SkyTel. People have called it skittily. Whatever. So yeah, well, what it actually means is, and it's a Greek word, obviously, and it's in Greek. They used to in Greece they used to spin things on a particular cylinder and just remove that and throw that and write something on it and throw that away, right? So on the other side, a person who has a similar shaped cylinder can actually spin that thread and read the message. So it was kind of olden Greek cryptography, if you want to call that. So yeah, that's kind of where that name comes from. So SPIFFE stands for it's an open source specification. Unlike GraphQL, we actually did a reference implementation of that. So it's called SPIFFE reference runtime environment. So yeah, so that's what SPIFFE stands for. I've been working on this for about 2 years, close to 2 years now. Previously, I was working at Splunk on the cloud team, where we saw a lot of things about identity, how we're going to manage identity of microservices, right? That's kind of what SPIFFE kind of tries to solve. So that's about me. A little bit about the timeline of this, right? So who here is familiar with Plan 9? Who knows Ken Thompson? Ken Thompson, Rob Pike. Rob Pike is kind of like a Go founder. So a bunch of folks, right, smart people, joined Google, and they were, Plan 9 actually is an operating system wherein they have namespaces for every single process that is running, and that's kind of more like a, similar to Unix, but with namespaces allocated for each individual process. So that's kind of what it was, and folks who went there kind of started at Google. Obviously, Google has all these microservices. That's where all the Kubernetes stuff comes from. They have Borg internally, which is called Kubernetes. So SPIFFE is something that was initially called, or is called LOAS, Low Authentication Service. That's what LOAS stands for. So that's where SPIFFE comes from. So Joe Beda, who initially wrote a paper or did a presentation in BlueCon back in 2016, he presented something about SPIFFE and what his thoughts were. We kind of took that and ran with that and actually came up with a reference implementation for that. We did closely work with Joe Beda and everybody in Google, Netflix, and Facebook, and all these big companies to actually they are part of our SPIFFE community, and we're trying to have this as an open source community. And in 2017, we actually became part of the CNCF project. CNCF, for folks who are not familiar, is also part of Linux Foundation. And we are what is called a sandbox project. CNCF gradually graduates each project into different sectors. So sandbox is kind of like the very, where you step in and graduate upwards. So that's a little bit history about it. So talking about why, right? Like, what is the motivation here behind, like, what exactly are we going to do about SPIFFE, right? Like, why do we need SPIFFE, or what exactly is it trying to solve? So here what we have is, we can start a conversation with a typical infrastructure, right? You can substitute whatever you want, those names don't matter, but this is the complexity, or just to represent the different interaction or communication you need. Like, you'll have a system that is a web front end, and people want to move towards mobile, and they have their own mobile API, and then you have your more sensitive information that is towards like billing, or like actual membership data, information about the users, so such things, right? So depending on what interaction is happening, there definitely is a necessity for different software systems to communicate with each other, right? So on top of this, you have different providers. So this is not like just to like, let's just try out some different thing, but there is an actual necessity, right? Like for SOC 2 compliance, or for some sort of a compliance like GDPR, for that matter, right? You need to have data on-prem and more secure. Like you talk about banks or financial institutes, you want those to be more secure, right? And obviously, like you have some infrastructure, you don't want to be, pulled in by a single vendor. You want to have your services across multiple vendors like AWS or Azure, things like that. So more increasingly, like there are other factors that affect your infrastructure decisions, right? You want to move to Kubernetes. You want to be able to have a ephemeral container-based orchestration systems which bring up spin up microservices and allow you to only use certain amount of resource for that specific query, for that example, for a metaphor. So that's how our current landscape of different services look. Add to that, you actually have third-party systems, right? You want to integrate with Twilio, you want to integrate with SendGrid, Zora, you name it, right? Like, so infrastructure is no more something that used to be like, let's say like 10 years back, right? 10 or 15 years back for that matter. So in this complex infrastructure, how do you make sure that your communication is secure, right? Communication between the services itself is secure. So let's look at what we did before, right? Like, so before all of our stuff was in a firewall, all of our stuff was on an on-prem. There were less number of services, less number of systems, so you could build a firewall around it. You could own the network, right? So you could rely on the network. But not anymore, right? Like now you have, like, obviously just looking at this, you cannot own anything apart from your on-prem system here, right? So, so what do you do, right? So there are multiple solutions, there are multiple frameworks that allow you, one for that matter, Steve was mentioning earlier, like the Cognito, or AWS has IAM, all those things, right? Like, what is actually the commonality in those systems is, it can be like, let's say like a web front end wants to talk to a subscription service, right? So you have each service having a way to generate a username and password, right? And that username and password somehow needs to be injected when a new microservice comes up, right? So that is, how are you going to do that? How do you make sure that it's secure? You cannot bake that username, and maybe some people do that, but that's not the right way to do it. Like you don't want to, key material should not be on baked into an image or anything like that. So that's the question, right? Like, how do you make sure that you want to be able to, have a much more secure way of doing these things, right? So first thing you generate those key material, then how you bake that, or how do you make that key material available to your microservice, right? So these are the challenges, right? This is the problem with this particular model, right? Moving forward, you have like something called platform mediated way of identity. So the password, that is kind of what is your identity, a microservice identity or a service identity, right? Here what happens is in AWS you have instance metadata that you can retrieve for that particular EC2 instance, for that matter. Or in Kubernetes you have like service accounts, right? Let me know if I'm telling too many jargons or names that you want to need any clarification. Please stop me and ask me. I think there's too much information that I'm assuming. So yeah, do let me know if you have any questions about it. But yeah, so the idea here is you have a platform, right? And you deploy your service on the platform, and the platform, since that platform already knows about that particular deployment, it can identify that through some privileged APIs or something in the background that you can check, and it can identify, it can provide a platform specific identity, right? That platform specific identity in AWS is called the instance metadata. GCP has a similar thing, and even Azure has a similar thing, right? If you go to something like Kubernetes, which is like orchestration, there you have something called a service account. So each service account, each kubelet in Kubernetes can actually retrieve a service account based on the pod spec, and further in the pod spec you have the containers that it's running, right? So it can pull that and provide that service account as an identity for that container or for that microservice that it's running. So that's all nice, right? So what is wrong with this, right? So for one, you are kind of married to the platform itself, right? If your deployment is on AWS, you cannot use that identity on Azure, or if your deployment is on GCP, you cannot use that same identity to authenticate against a microservice that's running in some other platform, right? So that's the problem. So another thing is, even though if you're running Kubernetes in the same place, but on a different region, right? For that matter, a service account is only tied to that particular Kubernetes cluster. It's not necessarily tied to something that is in a different Kubernetes cluster. So your identity is limited to where your microservice is running, right? So how do you solve this, right? So what you really want to do is have a federation, right? So you want to federate the identity across vendors, across your on-premise services that are running, or for that matter, something like a function as a service, for that matter, like a platform as a service, or even for a function as a service, those identities, right? So how do you do this, right? So what do you actually need to do that? So you need a standard, right? You need all of these components here, all of these different providers need to understand and come on terms with a standard, right? So what is that standard? That standard is what SPIFFE is, right? So what is an SPIT is how do you securely, it's a certificate, right? You can think of it as X509 certificate, wherein you have, it actually is, X509 certificate is one of the formats of an SPIT. We even have like chart, which has like claims and issuers and all those other things, right? So think of it as a certificate instead of the certificate saying I am yahoo.com. Who knows Yahoo anymore? Anybody? I used to work there a long time back, but yeah, so google.com or yahoo.com. So how do you identify, right? Like similar to HTTPS, you have a certificate there, you have a CN which says this is yahoo.com, and you have all these trusted authorities which say that is who that website is, right? So similar to that, you can think of a service or a microservice or a workload to have a SPIT, so which has which is the X509 certificate, which says this particular service is trusted, and its SPIFFE ID is this. So in X509 spec, you have SAN URI. So that SAN URI is what SPIFFE ID uses as to identify that service, right? So you need a standard, and you need a way for any microservice to get that SPIT, right? So you need a standard way. So if you're thinking about going back to the previous slide, like if you want all of these systems to have a standard way of like getting their identities, right? Like all of these workloads that are like those green bubbles, which represent there. If you want all of those to have a same way of identifying with each other, then you need each platform should have an interface, right? A workload API that also needs to be part of the standard. So that's what a workload API really is. And another important thing that needs to be there is how do you federate between the different orchestration systems, or for that matter, different vendors. So you need a federation API also to represent that. So I'll go in detail on these individual things so that it's much cleaner. But this is the idea, right? Like, so high level picture, you have SVIT through which workloads authenticate each other, right? So SVIT represents your workload identity. You have workload API. Workload, I'm using microservice and workload as interchangeable. Workload is more a generic term to say not just microservice, but also legacy services like database or whatever you want to connect it, right? So you need a way for those systems to actually, like a common interface through which it can get its identity, right? So that's what a workload API is. And federation API is how does two different cloud vendors or systems or platforms communicate with each other to represent that, communicate with each other and say like, okay, these trust root can be trusted. These roots, CAs, can be trusted, and that's how they communicate. So we call, in SPIFFE, we call that like a trust domain. So how do you federate between these two trust domains, right? So that's what federation API gives you an interface to like do that, right? So that's all the motivation and how you can do that. Yeah.
Can we ask questions right now?
Yeah, sure. Yeah, go
So
for
if
it.
you go back to the previous slide, so these workload APIs, who are they talking to?
So a workload API is requested, right? Like a workload or microservice requests a workload API to retrieve its identity.
Okay, so there is no central piece where they're talking to, or is there a central piece that they're talking to?
Yeah, so here like that's called a Spire agent. I'll go into that in a bit. But the idea is this is the standard, right? So this is the standard. What this is representing is a standard. So you need a SPIFFE, which defines, which is a document which defines who you are, right? And a workload should be able to retrieve that document using workload API. So that's the idea there. You have a question? Did you have? No, sorry. So more in detail, right? So deep dive into this. What is SPIFFE and what is exactly Spire, right? So this is a SPIFFE ID, right? It's a URI which says, like replace whatever company or part of domain, like oracle.com can be a trust domain, or pleasanton.oracle.com can be another trust domain, right? So that's a trust domain. And how do you identify a workload is through the remaining part of that URI. So this is the standard way of representing a SPIFFE ID. So that's a SPIFFE ID for you guys. And the verifiable document is SVID, and I think I already covered this, but it's basically a X59 leaf certificate which has a URI SAN with that SPIFFE ID. We are also working on chart-based SVID, wherein the issuer will have the SPIFFE ID if you're familiar with charts. So that's another way of doing that, but that is still in experimental sort of mode at this point. So what exactly is a workload API, right? So it is what I kind of mentioned earlier. So a workload says, who am I? And by some native, more secure, like if you're depending on your platform or where you're running, the Spire agent would be able to identify you. So in terms of if you're running in EC2 instance, there is things like instance metadata, which kind of identifies. So that's kind of going into a platform specific attestation, right? Like you say that this particular workload belongs to this this particular node has this metadata, so this is a valid identifier for this, right? Instance identifying document. So that's what AWS provides. If you're more running this on-prem, there are other things that you can identify based on the kernel level itself, right? Like in your kernel, you can look at what particular process ID or UID that particular process has. So that's kind of called a kernel level attestation, right? So that's just I'll show you in detail in the demo what exactly that means. So high level, this is more like a server can run all these workloads, and there's a workload API that is exposed by something on that server that is running, which kind of gives you a cryptographically verifiable document which says this is who you are. This slide's kind of shows you at a high level what federation looks like. So you can think of each of those boxes as being separate Kubernetes clusters, nodes in a Kubernetes cluster, and there can be other deployments, other EC2 instances, or some other instances. All of those, the dot there represents a Spire agent, right? So this particular dot here, kind of I don't have a pointer, so I'm trying to point it, but the dot represents the Spire agent, and the federation is represented here between two Spire servers interacting and exchanging the trust domain, trust relationship there. Any questions so far? Are we all on the same page, more or less?
Yeah, question.
Yeah.
So when a workload talks to workload API says who am I, and it gives a document. So do we have to register first or a trust domain? How does the workload API identifies that? Can you go back to the?
This is exactly the slide you were asking me a
Oh,
question about. So what you do is you register, right? So when you, I'm not sure if, let me know if this answers your question. So when you have a Spire server, you have a Spire agent running on a node, right? And how does a Spire agent know that that workload needs to get this SPIFFE ID, right? So that's what. So initially, the first thing you do is when you bring up a Spire server, is register it, right? So register a SPIFFE ID. What does that mean, right? So you want, let's say, like the workload on the right here needs to be identified with payments, right? That's its SPIFFE ID that it needs to be represented with. So you have a bunch of selectors with which are kind of like native attestation, if I can call that. Like I'll show you what that means in a bit, but what selectors are is identifiers which are native to where that workload is running, right? So you can think of a very simple selector being like UID 1000, right? So if you're UID 1000 running on that server, then you will get a SPIFFE ID associated with that, right? So multiple selectors, you can have a user ID, you can have a group ID, or I'm just talking about like kernel level attestation, right? So user ID or like group ID, all of those can be selectors, and if that workload or that process or microservice, whatever you want to call it, is running as that user or belongs to a user that or as a user that belongs to a group, that Unix system, then you will get that SPIFFE ID, right? So that's kind of like a kernel level attestation. Similarly, you can think of if that node itself, right? So there are two SPIFFE IDs, so one for the node and then one for the workload, right? So you can think of so if you're running your service or workload entirely just on one particular node, then that means that node itself is representing your microservice, right? So in those situations, you can think of that selector being like belonging to that security group. So SG here, like AWS security group. So if your node is running on that security group, then it gets this SPIFFE ID. So the selectors can be like very varied, and you can write your custom plugins in Spire to like identify what those mean. But here we are just saying that if you're running on Kubernetes and you belong to this namespace, then you get this SPIFFE ID, right? Or if you're a Docker image and your Docker image ID is that, you can also think of it as like some binary SHA that represents your binary, right? Like the last time folks over here, like Aqua Security or whatever, they were talking about like container, and so those can also be like strong selectors that identify and provide you those SPIFFE IDs for your workload, right? So does that answer your question?
Yes.
So let's talk about what are the use cases, right? So obviously there is authentication, right? This is, there is a source, there is a destination, and you want to authenticate or create some sort of a TLS connection or mutual TLS connection between them. Then you already have a SWIT through which you can have that communication authenticated based on the certificate and create that connection, right? So that's one use case, or the main use case of this. But it doesn't stop there, right? Like you can have like a proxy, so wherein you can define like once you have authentication, obviously you can define like authorization policies around that, and you can say this microservice has authorization, or this SPIFFE ID has authorization, excuse me, so to talk to only these other microservices, although it is belonging and authenticated, even though there is TLS is connected, but you can have authorization on top of that, right? This can be used with Nginx. That's a demo I'll be showing later on. Or this can be used with service mesh, like Envoy or Conduit or any other like service mesh as well. If that service mesh is able to understand what SPIFFE is and figure out what that SPIFFE ID is, right? You can further leverage all those nice little things that nice and important things that the service mesh gives you, right? Furthermore, you can use something for telemetry, for metrics, for log. Once you have a strong identity, you can represent that identity anywhere, right? So those are the other use cases that you can use SPIFFE for, or SPIFFE idea. So this is again for a CI/CD deployment sort of a thing, wherein you can say, okay, you can base your selectors based on that, and you can strongly say that this binary has this privilege, right? And it's actually built, right? So that's another thing. So are you guys familiar with Beyond Carb? This is kind of like a Google thing, wherein you say every single laptop, every device can be strongly identified to belong to this particular group, right? So HSMs and things like that, at device hardware level attestations can be done, and depending on it's basically saying there are no internal threats because all your devices are being tracked. So if there is external devices that are coming in, those can be identified based on the hardware level identity, HSMs or something like that. And those use cases can also be used. I mean, I'm not saying this already exists, but these are use cases that SPIFFE can be used for. So yeah, you can also call I left that slide, but there's something called secure introduction. Are you guys familiar with Vault or some sort of a secrets management store? So Vault is actually SPIFFE enabled, as in you can actually HashiCorp, we can work with them to get SPIFFE natively supported. So once a workload has its identity, right? It can use that SWID to interact with Vault. So Vault can verify that SWID, and you can get secrets for something else, right? So you just have the same identity, but you're now securely introducing your workload to that secret store. That way you have a way for that microservice to get secret, key material to interact with some other system, right? So the same identity, you can swap that to get some other credential, which you can interact with some other non-SPIFFE compliant software, so to speak. So overall, that's kind of talks about identity plane. Let me just skip this part and actually do this. This is kind of like Spire. We talked about the selectors. This is more the kernel level attestations that we talked about. Let me just do this. I will skip this and talk about this as part of the demo itself. So this is kind of the demo that we're gonna show here today. So we have a Spire server, right? It interacts, so all of these connections are basically gRPC connections here, or TLS, right? So MTLS connections with gRPC. So that's what's going on here. So we have Spire agent, and there is a front end, right? Nginx front end, some regular application, we took from GitHub, some repo. So there's nothing special about that. There's nothing special about the Nginx blog either. So it's basic. For all practical purposes, it's not an application. It's just a page, but it authenticates using Nginx, which is the proxy that understands. So we made modification or a module in Nginx to be SPIFFE compliant. and that's how that particular application retrieves its identity, so that you can talk with another application, right? So this is kind of the overall thing. Like, there is a Spire server that we are running, then we have a Spire agent that's running, and then there is Nginx in front of that, and Nginx does your MTLS for communication, or securing the communication between the applications. So that's the gist of that. So how do we do this, right? So anybody familiar with screens, GNU screens? So I am not, so I took a while to like figure out how to copy paste, so bear with me when I'm doing this demo. So so here is, so there are 6 panes here, right? So the first one is a Spire server pane, this one is a Spire agent pane, and these are you know, like the blog and front-end application panes, right? The second row here. And this is kind of like afterward, just look at the certificate, expand on certificate, and just like manipulate some of the Nginx configurations. So this is another thing, or down here. But let me just try and copy paste some of the stuff so that I don't have to type too much. But the idea is, so you start, by the way, all of these this particular demo, and there are some more other demos, they're all on Spire GitHub repo, so you guys can, like, you know, just follow the instructions here, and later on, if you want to feel like trying it, just follow the instruction, and it should be pretty straightforward for you to like run this in your own time. But we start the Spire server, right? And we kind of like register Spire agents. Sorry, I just need to clean that up because so this is all in Docker Compose, so obviously I cannot bring up an entire infrastructure to do the demo, so I'm just representing things here. So so Spire server, so I'm starting the Spire server here. Now the next step here is to like register your workloads, right? So how do you register this? I'm just copying this so that there is so what this is saying is, for a host, right? So this is the example.org is the trust domain, and for this host as in the node that it's running on, has a way for you this particular host can actually like provide front-end SPIFFE ID if the selector Unix UID is 0, right? And this is just a TTL for representing that particular, how long that SPIFFE needs to be run. So, any questions there? Yes.
That demo, can I run the ECW with the Docker?
I'm sorry?
The demo you're just making, right?
Uh-huh.
Can I use the ECW with Docker?
ECW?
Yeah, the Amazon.
Oh, EC2. Yeah. You can use a. Yeah. EC2. You can definitely use EC2. Like, there's a separate demo I can show you like later on, but you can definitely like bring up EC2 instances. Just plug in your AWS key in there, and all of this can be like brought up on EC2 instances as well. So yeah, I just, for simplicity, I'm just sticking to like like kernel level attestation using like Dockers here. But definitely at some later point, if I get another opportunity to do this, I'll probably show you guys the EC2. But yeah, so this is the end. Like the entry that we call it a registration entry. This is how you register a microservice as to what SPIFFE ID it needs to get based on the selectors there. So we can register a SPIFFE ID for the front end. Now we'll do the same thing for the blog microservice. So we registered the blog microservice as well. So that kind of takes care of registering. Since this is a Docker demo, then we don't have a strong way of attesting a node. So what we do here is something called a join token. Like this is like a nonce, like a one-time bearer token that you can use to. So this is where I need the screen copy paste skills. So 1 second here. So yeah, so basically what this is allow for an agent to attest with the Spire server. So you use that, if this was EC2 instance, then you would do like a platform-based attestation, wherein you have like IID through which you can retrieve that and you can attest based on that. But since we don't have that, what we will have to do is just go with like a bearer token, like a sort of, we call it join token. So when I say bearer token, any node that has that token can attest. So it's a one-time bearer token, which is what nonce is. So that's what that is. So you use that, and so now the host is, so here, visible, yeah, okay. So is that visible to everybody here? So yeah, so that's kind of like saying you signed SVID and assign that SVID to that particular node, because that node just now attested saying that with a generated nonce from the space server itself. So next step there afterwards would be to actually run Nginx, right? So this Nginx has like a special module which is SPIFFE enabled. So that is running the blog, right? And now I'm going to do a similar thing for the front end. So what happened just now, right? Like the screen all went like. So what happened with that is it says both the workloads actually like attested to the agent that's running, right? So the agent is running on the top right, and these two workloads, since I started them, authenticated or attested to the agent and the agent was able to identify them because we use the selectors UID, right? So these are running in our Nginx configuration. We are running those applications as the registered belong UID, right? So the user that this process, Nginx process, is running is already registered on the Spire server. So that's the reason it was able to like attest and actually provide SPIFFE ID. So let's just go here. I'll just do a simple. It's running locally, so it is authenticated now. So this is a TLS connection between this. This is actually an MTLS connection between the front end and the blog, which is using the SVID that was generated by the Spire agent. So that's how it's communicating. Let's try to like look at that, right? So we have some. So this should actually have like a front end SVID here. So here, this is the SVID for the front end, and if you look at the sign URI, subject alternative name URI, you have the SPIFFE ID of that particular is for the front end, you have this. You can definitely look at the other SPIFFE ID for the blog. Sure enough. So here you have the SPIFFE with the SAMU ID for the blog. So let's try and see, like, change something in the configuration itself, right? So I'm going to look into the front end, right? And here you have a directive here, an Nginx directive that says accept SPIFFE ID block, right? So that's what is defining that TLS connection. So I'll just go ahead and insert something in here, right? So just to make sure, just show you the other use case wherein it should not authenticate. It takes a while for it to like reload the configuration. That's why it's right now. So that kind of like blocks that as because it's talking to a proxy, it kind of treats it as a gateway. That's why you're seeing a 502 instead of like a 403 for that matter. But that's the idea there. But if you do the same thing on the blog, it will give you 400 error here. Yeah, although it auto reloads the configuration, it takes a while. I'm not sure why Nginx does that, but it has some latency there. So if you guys are more, we're waiting on that, like if you guys are more interested in more detail or anything like that, like there's this Spire repo, right? And our workload API is kind of like defined here. It's a gRPC endpoint, which is defined at protobuf. So what it does is, basically fetch X509 SPIFFE, right? So it does not take any other. These are all experimental, right here for JOT, but mostly this is the only method that's currently supported. So yeah, if you guys are more interested, let me know. I can do like a different session to go into the details of how you can actually start contributing towards it. So that kind of gives a 400 there. So yeah, any questions? So these are our like presence on the web. We have a Slack channel, spiffe.slack.io, which is open to public, so anybody can like ask any questions, anything like that. We have a couple of blog posts. I wrote one of them. There are other similar like online and other integrations that if you guys are interested, if you can, want to ask more comments. Yeah.
In your demo, you are connecting to local host, right? You are missing some part here. When you connect to local host here, right? You are basically using a REST call, right? So is this SPIFFE is going to modify the REST interface over there, or basically you are securing the communication between two hosts, right? Which are kind of completely disconnected from network. They are no way connected, right? So even though this guy is using only REST call, right? How does they identify each other that okay, this is my trusted entity, even without adding any additional headers or any other property to the REST API call?
So the local host that I showed is basically my interface to the Docker containers that are running locally, right? So so when I brought up the demo, so there are few things that actually like in the Docker Compose, like few containers that came up. Like one is the Spire server itself, right? And then there is another Spire agent or another node, and then there is Nginx in there, and then there is your front end and block applications, right? So when I connect to the local host, it is actually like connecting to the Nginx, right? So it is connecting to the Nginx, and let me just show you the
If you have demo, if you can go to your architecture,
yeah. So here, right? So when I connected to the front end, it's not. I'm connecting to the front end, right? When I hit localhost, I'm connected to the front end. So that is not secure. That is not HTTPS or anything, TLS or anything like that. But when front end, so the whole thing is about like microservice interactions, securing that communication, right? So the front end to Nginx communication is what is secure, right? So how
So
Nginx?
let's say for example, here
Yeah.
for front end, if I'm making a REST API call to this block
Right.
service.
Yeah.
So in that process, right, can you, I mean, walk through step by step over there, like when the front end is making an HTTP call to log, right?
Yeah.
Will it connect to Spire server first or Spire agent first?
No. So
One or
right.
something or
Yeah. Sorry, I did not explain that well. But so there is no connection with Spire agent. Once a workload gets its identity, that's it. It does not connect again to Spire agent unless it needs to rotate its identity, right? When the MTLS is only between the workloads or between the microservices. So once you have that certificate, your TLS certificate, you just use that certificate to X59 certificate. I'm sorry. Once you have that X59 certificate, you use that certificate to establish the TLS connection, right? So you don't talk to Spire agent or anything like that. So Spire agent only provides you that X59 certificate. So once you have that, then you can use that to like create your TLS connection with any other microservice.
so how it's different from like, because right now also if I want to trust two services, right, I can put the X59 certificates in both the things and make them trusted entities, right?
Right.
So whichever calls come from here, it is always kind of trusted,
Right.
End of authentication is it.
Right.
So I can do that without this also, right?
Right.
Without Spire server also.
Yeah.
So what is the additional advantage I'm getting if I'm using Spire server?
Right. So the Spire agent, you don't have to do that, right? With Spire agent, you don't have to like create certificate or provision your microservice with that certificate. All you have to do is deploy that microservice, and the microservice itself retrieves that X59 certificate and manages it and rotates it, and based on your configuration can actually like have like, different routes, right? Like you have different routes and trust those different domains.
Yeah, but before doing that, we have to establish some kind of that happens by registering into a Spire agent, right?
Yes.
So it's the same process that you have trusted CAs on both the ends. Similar to that. I don't know if that
Yeah. So this is different in, you think of it from a microservice or like ephemeral sort of services that are always like in Kubernetes, right? Like you have all these containers coming up, your pods are coming up, they're going down. You cannot like in your previous, like if you're managing those services by yourself, then you have the privilege to like, I'm not saying that you cannot create a certificate and like put it on a service, but in an orchestrated environment, you cannot do that, right? Because things are coming up ephemerally, right? They're coming up, they're going down, and how do you, like create that, right? What is the identification that your microservice has, right? So so basically in you can establish, you can create a certificate, and you can provision that microservice with that certificate. But how do you rotate that, right? Like, even if you do that, how are you going to rotate that? You're not going to like go and like manage that certificate for every time the microservice comes up, right? So that's what is different about like why do you even need this in a Kubernetes or a CNCF context? That's what it is, right? So you need something that manages your key material. So that's what Spire is actually helping you do that.
I have a few questions on if you have multi-cloud infrastructure, is the Spire server will be different for each and every cloud, or how?
No, so that's a good question. So Spire is based on, if you guys are familiar with HashiCorp, like any of those, right? It uses the same exact plugin model that HashiCorp. We literally use the same plugin model. So you can have attestations for Node. You can have vendor-specific attestations. You can write your own attestation plugin if you want. So we just defined those interfaces. Right now we have support for AWS. I want to say GCP and Azure. I think I might be wrong, but Azure I'm not sure if it's existing. But there are different attesters, right, which are like plugin interfaces that you can plug in into Spire when you're deploying it on those specific things. So there's also Kubernetes specific attester, things like that. So it's very pluggable and like customizable architecture. Yeah.
How the agent, like we have the one of the diagram, like we have multi Kubernetes clusters and talking to like servers, right? So those many agents will talk to servers. How that scalability will be happening? Like how frequently the communication between the agent and the servers happen?
It depends on, so there are two things, right? Like there's HA, right? How do you manage HA, right? So that means you need to like scale up your Spire server. So which is definitely something that's possible, right? You can bring up like multiple Spire servers to maintain that HA. That's one thing. That's how you can like have like n number of agents. But more importantly, what is it is like how does in X509 you have a root, right? You have a root. So how does that root in your chain of trust? How does that actually happen when you're HA or you're scaling, right? So one thing that's what the Federation API is about. How do you make sure that the chain of trust, right, is maintained, still maintained? So one way of doing it is actually exchanging that root between the federated Spire servers, right? That's still an ongoing conversation, so to speak. But yeah, I mean, you're more than welcome to like talk about it in our Slack, where like there are more people who are actually working on that, right? So they might be better positioned to actually say what is the latest and the greatest on that. Yeah, that's the idea there.
One more additional question, sorry.
Sure. Sorry. Sorry, is that it?
At the API
We'll take this as the
level,
last question.
Yeah.
within the microservice at the API level, is it possible to make, apart from authentication, you can do authorization as well?
Definitely, yeah. Not with Spire, but you need some other additional tools or something like that. Yeah, there are other, like in Kubernetes, you have all these RBAC policies that you can define. Istio does this, like Istio actually like is SPIFFE compliant. Most of the people who come to SPIFFE they look at Istio and think that there is a Spire agent running in there, but it's not the case. But they have their own implementation, or like they basically have certificates which have SAM URI, which is a SPIFFE AD. So yeah. Thanks guys, thanks for the opportunity. I'm happy to like, answer any questions in Slack or anywhere else. Thanks.
So as always, we have the room for another half an hour, so feel free to stay back and network. Yeah, thanks for coming.